Great to have you here with us today, sir. We truly appreciate you taking the time to join us today. Sir, you're inaudible. Can you go again, please? Hello.
Yes. Hello.
Okay. Uh, so,
Yes. Now I
so
can hear you. Correct. Great.
okay, fine.
So
I'll
thanks
just
for the introduction, and also saying hello to Anand and Sanya.
So we'll proceed, and I'll quickly introduce the company and the speakers to the audience. So, Nadcab Labs is a leading blockchain development company, and we've been actively building in the space since 2017. And we offer end-to-end software development solutions, including crypto exchange development, DeFi platforms, custom blockchain development, Web3 applications, NFTs, and much more. And our focus is basically on helping businesses build scalable and future-ready technology solutions. And now I'll introduce my colleagues who will be joining the session today. So we have Anand here, who is a Web3 enthusiast, and Shania. She is a crypto community manager. And I'm Ruchi, your host, and also a Web3 growth lead at Nadcab Labs. And now we start the session. Could you please introduce yourself to the audience, sir?
So you are asking me to introduce. Perfect. So thank you, Ruchi. So I I am Tarun, as you mentioned already. That okay, I am right now working as a founder and CTO for Let's Practice Academy. I'm also an author of various books on cloud native technology, microservices, software design patterns, and have around 20 years of experience in industry. Have worked in big tech firms including Microsoft, SAP, Oracle. Have worked in various positions as a senior software engineer, architect, engineering manager, director. So definitely, glad to share and talk about this wonderful topic, that we will be going to discuss. And nice to know about the NetCab Labs, and looking forward for discussion.
Thank you so much for sharing. I'll start with the session and I'll take up the first question. So, what does IT infrastructure really mean, and why is it the foundation of every modern digital system right now?
Okay, great. So yeah, just before I start, for Anand and Sanya and you also, Ruchi, you can be interactive. You can interrupt in case you want some more clarification or if you agree, disagree. So I love keeping the discussion interactive. So here, coming back to the topic about ID infrastructure. So as we know, all businesses depends on now their digital presence. IT infrastructure is everything which is hardware, software, and the network resources which are required to run for any enterprise various softwares, websites, applications for their operations. So it's all about computing power, storage, networking, and it includes important considerations like security, connectivity, and it's basically the platform to run applications. So now, no interesting thing. Now, when we talk about the IT infrastructure, it's all about cloud. So now, industries, various, whether it's a technical firm or a business firm, they rely on cloud providers. For example, AWS, Google, or Microsoft Azure. So earlier were the days where people used to buy physical hardware, physical servers. So you all know that these have disadvantages, that you have to do a lot of capex expense to start with, and you don't get that flexibility because if you want to scale, you have to purchase more hardware, and many times the resources are not utilized, so there is underutilization. So there were various problems which were around physical hardware. So now industry has moved to cloud. So that is, since last 10 plus years, we have seen there have been massive transformation of cloud. So now coming to, we were talking about physical servers. There is one interesting term you would have also heard about. This is called bare metal. So physical hardware, is a hardware which is mostly you procure big servers from either HP, Dell, or any hardware vendor. So companies earlier used to spend uh, millions of dollars to build a in-house data center, but now it's not required. And now the cloud providers, they provide two kinds of access to the infrastructure. One is virtualized servers, and the other one is bare metal servers. So the interesting thing is, when we say that, okay, everything is running on the cloud, it's running in multi-tenant mode. So that means not only your business is utilizing the same server, this server is shared by multiple customers or multiple uh, businesses who are also like you running their apps. So uh, now important thing is, if you are wondering what is virtualization, virtualization is a technology which allows a server, a physical server, to host multiple logical servers. So that is actually about virtual machines. So now businesses can use virtual machines over the cloud. Now, the other problem with this was virtualization solved many problems. So, for example, I was mentioning, you don't have to pay upfront cost to buy the servers. Server is maintained, and everything related to upgrade and patching, security compliance is taken care by the cloud providers. But you have to pay subscription. But then with these additional layers, and as I say that, okay, multiple businesses are also utilizing the same hardware, and you are getting a virtual machine, not a dedicated physical machine. So there were some performance overhead as well. So now industry also came back to another kind of environment, which was bare metal environment, where you get direct access to hardware in non-virtualized manner, and the hardware is dedicated to you. So sometimes the term is used very interchangeably: physical machine, physical servers, and bare metal. But I want to make this very clear that there is a slight difference. As I said, physical server may have a bare metal access, or it may have a virtualized access. So all bare metal servers are physical servers, but not all physical servers are bare metal. So this distinction is very important for engineers and for technocrats like you to understand. And then know bare metal, as they don't have any virtualization layer, they provide fast access. And now in scenarios where we are running AI workloads, which is compute heavy, and also Web3 based application, blockchain based application, where also a lot of computations are required. So it becomes important to have good performance. And virtualization causes some additional overhead because it runs on hypervisor. So not diving into too much of the technologies, but this is an important distinction which I would like to share, that no, there is two different kinds of infrastructures which are available. One is the virtualized environment, and other is the bare metal. And based on your use cases, if you need high performing use cases, which is important for finance app, say for example, if you have a stock trading app, then this becomes very important. Or if you have any AI application, there also, if you have to train models, you have to run inferencing, then bare metal capabilities are required. But in virtualization, you generally use simple applications or traditional applications, which could be any application like websites or some web applications, where your server is split into multiple logical units, which are called virtual machines. And you can scale and you get cost efficiency with virtualization.
Okay,
So,
I have a next question.
sure.
Yeah.
How did
So since we
virtual
said, no, no, Anand, just hold on a second. So since we said that this would be more interactive, so we'll ask you questions one by one and then you can answer.
Sure, sure.
Okay. So my next question would be, containers became a major breakthrough in software development. So for someone who is new to the space, how would you explain containers and why they transformed modern infrastructure?
Absolutely. Now, this is a very logical next step to learn about containers. So now you got an understanding about virtualization, about physical servers, about bare metal and their differences. Now, although these bare metal, they solved some problems, virtualization also solved a lot of problems, but still there were some limitations. So as I said, there was performance overhead, and the other aspect where the virtual machines were heavyweight. So containers are same or similar technology. So the foundation of containers are virtualization technology, but there's a slight difference. In virtualization, I said that there is you have a physical machine, then you have a hypervisor, which is engine where you have the virtualization mechanism or virtualization engine running, and then you have various operating systems. So there is different layers, and every virtual machine has their own operating system. So developers are very familiar with virtual machines because it's slow because of these overheads. Other thing is you can scale, but it takes minutes to scale because if you shut down and start, the entire operating system has to be restarted or shut down and rebooted. So they are not that fast. But in today's world, we need lot of elasticity in the infrastructure. So if suddenly the load increases, number of users visiting the site, traffic increases, we want to scale up our infrastructure and scale down also very fast. uh, so containers provided that flexibility. So they are lightweight virtual machines. You can think of it. They provide a standalone environment, which is very easily replicable. And when you run these containers, the containers share the kernel. So now most common container is the Docker, which is very popular these days, and it's a de facto standard in containerization. So with Docker, you isolate your environment. You only run the application and required runtime, which could be libraries, and this way, you can start and stop a container in milliseconds rather than in minutes. So containers provides a lot of flexibility, and because of these advantage, industry has moved to containers. And containers, they solve the problem which a lot of technical people teams face. It works on my machine problem. So a lot of times, the code which we run on our development environment works, but when we ship it into some production environment and when we run it in some production servers or cloud servers, it does not perform as expected because there are minor differences in operating system versions, or due to various reasons, due to dependencies, due to different versions of the library or runtime available. So there could be some side effects or no unknown issues which comes up. So that is a classic problem. It works on my machine, but with container, everything can be replicated. So this becomes very flexible for teams to not only run environment or applications in production, but also have some development platform which is easy to replicate. So this is helping a lot in automation. Perfect. So some other questions, Anand, you wanted to say something?
Yes, I have a question. First of all, a very good evening to you. And my question
Sure.
is, how are containers and microservices reshaping the way modern applications are designed and operated today?
Sure. Perfect. So now we were talking about containers, and we also talked about infrastructure and cloud environments. So now all the businesses are utilizing containers. They have got good adaptation, and cloud infrastructure has got good adaptation. Important thing to understand now: all businesses want automation in their IT infrastructure. So industry has also moved towards automation. What does it means is uh, you don't want manual intervention. So if you are scaling up and scaling down your infrastructure, if you are running test cases, if you are deploying, you would like to do it in form of automation through scripts, so that you don't have to have some person sitting and running some commands manually. Rather than there are some predefined scripts, there's a workflow which can happen and take care of all the steps which are required to ship your code from your developer machine to production. So this is what we call CI/CD, continuous integration, continuous deployment. The advantage is that you can ship more frequently. You can deploy more frequently to production, and you can deliver updates and changes and feature enhancement in much faster phase. So containers enabled the automation because for example, a Docker container, it not only just provides environment, they also provide declarative way to define the dependencies. And you can have images which can be stored in Docker registry, and you may have automation run through scripts. So that is a big change which has happened in the industry with containers, that everything has become more automated, and it is more reliable and predictable. Because as I said, that with automation, you get rid of the errors and you get more quality control, because you can test your code. So containers have been taken very well in the industry, and most of the organizations which are working on infrastructure, they have already dockerized their environments, and they are running hundreds and thousands of containers. So that has been the change. But now with hundreds and thousands of containers, still it creates another challenge of managing all these containers. So if you have a app where you use hundreds of thousands of containers, when to start, how to scale, how to run this reliably, how to monitor all these containers, and if some problem happens, how do you restart or ensure that there is reliability. So that is all called orchestration. So that is another challenge which has come up, and this is solved with the help of Kubernetes. So now Kubernetes is another tool which is for container orchestration, and this has become very important now with containers. So the industry has moved from now physical servers to containers and to Kubernetes clusters. So that has been a big shift. So what it means for developers are So now developers have to be aware of all these technologies. They not only have to know about the programming languages, databases, and various system design concepts, distributing system concepts like microservices, but they also need to learn infrastructure or platform engineering, what it is called. So this is a big shift now. Software engineers should not only know software engineering, they should also be aware of cloud, infrastructure, and platform engineering.
Shamit, can you please take the next question?
Great. So now, coming to you must be wondering. So we were talking about Dockers and Kubernetes. So why Kubernetes have become so popular? So the first thing is it solves the challenge of managing hundreds and thousands of containers. So now companies can manage these containers. Other thing is Kubernetes is built on best practices. It's backed by industry leaders, and it got incepted by Google, and they donated into cloud native foundation and open standard open source organization. So it's not like something which is a vendor specific or proprietary tool. It is an open standards technology, and it is available. Kubernetes clusters are available with all the cloud providers. So if you have AWS, you have Elastic Kubernetes Service EKS, or you have Azure Kubernetes Service, and you also have in Google Cloud Kubernetes servers or clusters available. So developers, they can run Kubernetes on their local environment, and they can very easily push the code to any of the cloud environment. So the same code not only works in now different environments, it can run on various cloud environments. So that is mainly the cloud native architecture, or I would say cloud native infrastructure. That means that the application is built in a way from scratch or from very beginning in such a manner that it can run on your local machine. It can also run on your servers within your organization if you have a data center or a private cloud within your organization. And it can run on cloud environments, not only on a single cloud provider but across all the cloud providers. So that is the real meaning of cloud native, that your application is designed in such a way that it can run on any of the cloud provider, be it Google or Microsoft Azure, or you have Amazon Web Services. It can work seamlessly across all the cloud providers. And any cloud provider, if they support Kubernetes, then you can very easily move your application across various cloud providers. Because the interesting thing was, when cloud came, the businesses and the solution architects, they started designing their application in a way which utilized some of the capabilities which were specific to cloud providers. Say, for example, in AWS, there was DynamoDB, and there are various proprietary technologies with the cloud vendors which are not open standards, and that makes the application very difficult to port from one cloud environment to the other cloud environment. And now, with increasing globalization, and with so many AI services coming in, uh, businesses would want to support multiple cloud environments, and Kubernetes enables it. It's the backbone or foundation of cloud native architecture. So that's why no, this is such an important technology, and it is nowadays becoming a very essential skill set to have on any software engineer for these reasons. Great. So
Uh,
hope you are getting what I'm saying, and any further questions, feel free, or we can move on to next topics.
yeah, yes, sir. So I have a one question. With AI agents, distributed systems, and event-driven architectures
Yes,
evolving rapidly, how do you see infrastructure changing over the next 3 to 5 years?
absolutely. Okay, this is a good question. So now we were talking about cloud, and one important term you have introduced, which is event driven architecture. So event driven architecture is an architecture in which various application components, they communicate with each other in the form of events. So, for example, if I'm placing an order in Amazon e-commerce site, and I'm saying order in my shopping cart, then there is a lot of other services which would be invoked when I will click on the order. Say, for example, there will be a payment service which will take the payment, and definitely my credit card details all will be shared, and it will be used to process the payment. At the same time, shipment will also happen. There will be notifications sent to my email inbox or SMS. So there will be a lot of services which will be getting called. So a lot of things in the background as well. For example, there will be analytics, there will be fraud detection, and all these transactions will be monitored. And stock will be reserved. So there is a lot of interactions. So what best way is to design such application is, rather than having asynchronous, rather than having a synchronous communication, have an asynchronous communication with the help of events. So there is a message queue, and all these messages will be posted, will be queued in a message broker, and other services will consume the messages and take appropriate actions. So this has become now a de facto standard. So event driven architecture has become a de facto standard because it increases scale. Because if some systems are down, then your interaction is not failed. You can restart that particular component, and the messages could be reprocessed. So it brings in a lot of scalability, it brings in reliability, and this has become lot of this has become de facto standard in lot of applications. So this is going to be seen more. All the AI based applications are now event driven. So this is event driven, and in blockchain as well, in Web3 world also, we have seen that there is a lot of computation which is required in background. So if you have high compute requirements, then this kind of pattern is very much suitable. So with blockchain, with AI, we would be seeing this more, and there will be services around this will be available more. Now, other important changes which we will see is monitoring and observability. So, if something goes wrong in microservices environment where you have hundreds of microservices, I gave an example of Amazon e-commerce app. So you can visualize that when I make an order, so many microservices are being involved. No, not only just the shopping cart, not only order processing, but it is payment processing, shipment, notification service, and many others as well for fraud detection, for analytics, and no, it is very difficult to kind of enumerate all of them because this is a long list. So these interact with each other, and this is possible with containers and Kubernetes. So troubleshooting and debugging if something goes wrong also becomes hard. So here we will see now observability and monitoring, whether all these services are running well, and they are running as expected with good performance, latency, and reliability. So monitoring all this will become AI enabled. So our rather than developers having to look into logs, looking into exceptions, and finding out manually what has gone wrong, where the troubleshooting used to be very tough and challenging task. This will become AI driven. The observability tools, they will identify the patterns and they will make it clear, and they will try to also resolve many such errors. And all our applications are becoming AI assistant. So now, after cloud native, what I see is coming is AI native. So AI native means AI will be embedded in provisioning of servers. It will be available in observability. That means monitoring and all will also be based on AI. So these are some of the important changes which we will be seeing more in coming days, which is around event driven architecture, around AI native architecture, and also around having a lot of observability, intelligent provisioning, and intelligent error recovery. Uh, these cloud platforms will become more autonomous, and they will become self healing. That means that they will be intelligent enough to identify the problem and recover, take some measures which will automatically resolve the errors which will happen in these infrastructure, which is complex to manage manually.
I have a concluding question for today's session. Is like engineers and architects who are entering the industry in today's time right now, what skills and mindset should they focus on to stay relevant in the cloud native era?
So now we should understand that for engineers, they are now overwhelmed because there's a lot of changes which is happening in the industry, whether it's Web3 world or AI world. But we should understand that Web3 is not running in some own cloud. It is using the same environment. So our cloud native architecture is the enabler of everything, whether it is about the blockchain networks or about AI models. So whether no GPU compute service is there, or training of models, everything is happening. Or on the decentralized app world, also in Web3, everything is being enabled this with this cloud infrastructure. So some of the fundamentals remains the same. So if an engineer wants to build applications on cloud, be it a Web3 app or AI app, he should be very much familiar with the networking concepts, because everything is becoming interconnected in the network and in the cloud world. So some of the fundamentals is still are very relevant, like Linux or networking, cloud fundamentals, learning about Kubernetes clusters, containers. So this is very important. CI/CD, and then there is another important technology which is about automation, which is infrastructure as code. So now with so many components on various clouds, we also use something called Terraform or infrastructure as code, where we manage all our infrastructure also in repositories. So that's infrastructure as code. Distributed systems mastery is also important, like what are load balancers, what are proxy servers, what is cache, different types of databases that should be understood. And event driven architecture, how to build event driven architecture. So we use distributed queues like Kafka, and this is now very important because any of the latest AI frameworks, they are working on Kubernetes, and they are having internally event driven architecture because they do a lot of processing. And if you use direct synchronous communication, the response time will be higher. So event driven is a must. And then we also discussed about observability, about monitoring and recovering. And there is a field called SRV. So this is reliability engineering. This has become very important. So these are some of the technologies one should master, and this has become very important these days. So now developers have to be, or software engineers have to be multi-skilled. So they should start uh, with the fundamentals, but then they should kind of add on all these concepts. So it will look overwhelming because it's a long list, but my advice is that no actual understanding comes when you do things in real world. So I will suggest people or students or new professionals to try out, build some projects, and learn that way rather than going through theories or looking into tutorials or videos. Real learning will come by working in projects, so they can start their own small project by themselves. And then it need not have to be a very industry great project. They can do some learning projects on their own and try to understand things on more deeper level. This will definitely help them build strong technical skills and stay relevant in future.
So thank you so much, sir. We were glad we were able to walk you through the session. And thank you for sharing all the insightful answers. And I hope everybody who joined us today also found the session helpful and valuable in some way or the other.
Great. Thank you, Ruchi. Thank you, Anand and Sanya.
Thank you
And
very much.
glad to meet you all. And this was a great session, on Friday afternoon or late afternoon. So, nice way to end up the work week. And wish
Sure.
you all the best and have a nice week.
Thank you,
Same
sir.
here.
Likewise. Thank you so much.
Great.